Good morning. It's Thursday, April 23rd. Today's video is going to be a walkthrough of the quiz that became active this morning. I'm going to talk you through the problems, re-explain how to answer them, and hopefully everybody will get 100% on the first try. Okay. Just a heads up, the math department is working on trying to find a way to pull off an end of the year math tournament. So that could be a lot of fun. I know you guys are really bright. If you have any ideas of like STEM competitions that you think the kids would be able to do at home with things that most kids would have in their home, feel free to message me. I would love to hear your input on that. Okay. Let's go to Pinterest here. First of all, today the quiz will become active on Edge Elastic. It's 10 questions. It's just like the practice. Not real hard. I'm going to show you the questions here in a second. My first Pinterest post, I don't speak kangaroo, but I'm pretty sure that's a last nerve warning. Don't do it again. You might be getting on your parents' last nerves about now. The middle one, when you're trying to figure out how this kid puts his shirt on. Yeah, I'm wondering. And over here we have Michael Scott, one of my favorite characters of all time. Time traveler. What year is it? Me, 2020. Time traveler. It's not good times. Not so far. Hopefully it turns around. For your quiz, all right? Questions 1 through 3 are multiple choice. They ask you to identify the system. Your choices are consistent and independent, consistent and dependent, and inconsistent. Well, consistent means the lines touch at some point, or one or more points. Inconsistent means they don't touch at all. Now, parallel lines, they don't touch at all. This would be an inconsistent system. All right. Now, your only other decision is which one of these is consistent and independent and which one is consistent and dependent. Well, think about independent, going your own way, doing your own thing, right? These two lines in this first problem are going their own way, doing their own thing, but they do intersect at one point. They are consistent and independent. This looks like one line, but if you look, these equations are identical. So these are really two lines, one line right on top of the other one. This is considered consistent and dependent because they do exactly the same thing as each other. Okay, so that's problems 1 through 3. Just want to make sure you have that vocabulary there. So questions 4 through 6 ask you how many solutions, okay? The first one or even two, I think I give them to you in slope-intercept form, all right? These two problems, these two equations are both in slope-intercept form. Because they have different slopes and different y-intercepts, they're going to have one solution. Anytime you have two equations with different slopes, there's only going to be one solution because they're traveling in different directions. At some point, they're going to run into each other, but that's it. Okay, that's the end of the story. They're going to run into each other one time. They're straight lines. They will never meet again. So a system like this with different slopes is going to have one solution. Does your mom ever do that to you? You don't get any chicken nuggets because you have food at home? My mom used to do that. Question, what is this? 1, 2, 3, 4. This is number 5. Again, in slope-intercept form. But what you notice about this one is the slopes are the same. Okay, that means these two lines are traveling in exactly the same direction. All right. Now, looking at the y-intercepts, they don't cross y at the same place. This one here crosses y at +4, so it's going to be higher than this one where it's crossing at -4. These are going to be parallel. They're not the same line because the y-intercepts are different, but they have the same slope, so they're parallel, which means they will never meet, which means the solution to this system is none. Is this you now? I hate it when people ask me, what did you do today? Like, buddy, listen, I woke up at noon and then it was 5 p.m., okay? I don't know. Not me. I get up at 6:30 every morning so I can be a teacher, work on my classes. Now, here's where it gets interesting because I'm asking you how many solutions, but I didn't give them to you in slope-intercept form. So with these, you're going to want to put them in y = mx + b form first so you can compare them. Should I go ahead and do that for you? I guess you should get some reward for watching the video. Those of you who actually are watching the video, and I know who you are now. That's right. There are people who keep commenting watched. And I know that means they're not really watching the video. And I'm super pumped that some of you really are watching. YouTube must have a problem because the views don't reflect what I'm finding out. I mean, I know there's more kids watching them than what I'm getting in views. So, yeah, pretty cool. Oh, and by the way, today for the secret word, don't do watched. Okay, watched means you didn't really watch it. I want you to comment your favorite color. Then I'll know your favorite color and I'll know you watched the video. So comment your favorite color. Alrighty, so back to what we were doing here. We would have to divide all three terms by 3 to get this in slope-intercept form, and that would give us y is equal to negative 2/3 x minus 1. Then you take the other one, 2x plus 3 plus 3y equals 0. We want y on the left, but we want these other two gone. So I'm going to subtract 2x and subtract 3 from both sides. And that gives me 3y is equal to negative 2x minus 3. Well, this is looking kind of familiar, folks. And some of you may be, yeah, I know how smart you guys are. You're probably going, oh, I wouldn't even do this last step, Miss Williamson, because I can see how this is going to turn out. But you know what? I became a math teacher because I like doing math. So, what do you notice about these two equations? That's right, they're identical. So, this line here and this line here are the same line, which means they'll have infinite solutions. Okay? Well, that was fun. Now, the last 4 problems. The last 4 problems ask you to find the solution. All 4 of these have one solution. You just have to find where they intersect, okay? And all 4 of these can be solved very easily using Desmos. Now remember, Desmos, you can download it to your phone as an app. You can access it on a computer or a tablet by just Google searching Desmos Graphing Calculator. Or you can go to McGraw-Hill, which I know is your favorite place to go. And Desmos Graphing Calculator is a little tab there. All right, let me fire up Desmos and I'll be right back and I'll show you how to put one of these in. Okay, here I've pulled up Desmos Graphing Calculator and I wrote down one of the problems. I'm not going to do all 4 of them. I won't bore you with that. But I want to show you how to go ahead and do this. The equation, the problem I'm doing is in slope-intercept form, but Desmos can graph anything in any form. All right, so I want to put in 1/3. So I'm going to do 1 and then I'm going to do the slash and the 3. Desmos gets that that's a fraction. Tab over, type in the x minus 2. Now we want to add an equation. The second equation is y equals negative 2/3 x plus 1. Desmos graphs them for you. Bring your cursor on over here, hover over that intersection, and the solution to this system is 3, negative 1. All right. When you enter that in Edge Elastic, just do parenthesis 3, comma, negative 1, end parenthesis, no spaces, and you'll get it right. Okay. So that's how I want you to do the quiz. I wish you the best of luck on it. Remember to comment your favorite color today, and I'll give you double extra credit for watching the video. You guys are awesome. I miss you all so much. See you tomorrow. Bye.